All right, this is a video on multiplying and dividing rational expressions. So if we focus on something complicated like this example right here, it could be a little bit daunting when you look at how many terms there would be to multiply, and you could end up, if you multiply this numerator times this numerator, as we would in a traditional fraction, you would do top times the top, bottom times the bottom, and then you would simplify your fraction from there. But when you get something complicated like these polynomials, then you're going to end up with what looks like 9 terms on the top and 6 terms on the bottom, and that just is a lot. So one of the things that we would like to do to simplify ahead of time is to go ahead and factor and try to cancel out where we can, like we were doing in the previous section. So I'm going to walk you through a few examples that builds to something like this complicated level, but to try to keep that idea of simplification in your head the whole time. All right, so here we go. Okay, so we're going to start slow, and then we're going to build up with complication level. First things first, we look here, and we don't have anything that can be factored out. No greatest common factor, no expressions, no multiple terms. It's just monomials on each part of the fractions here. So all we need to do is focus on this idea of top times the top, bottom times the bottom. But we can do some simplification even though we don't have to factor. For instance, any of these two numerators that has a common factor or something that it can quote unquote cancel with any of these other two denominators, we'll be able to do that. So let me just show you what I mean. For instance, the 4 and the 16, I think about those as 4 over 16, and they both have a common factor of 4. So 4 over 16 in my head reduces to 1/4. So that means that can cancel to 1, and this can turn to 4. So that's kind of what I'm doing in my head there. So I've got a 1. Sorry, I got a 1 and a 4. I focus then on the 15 and the 5. 15 over 5 would reduce to 3 over 1. So this turns into a 3, and this can become a 1. And now I've instantly shrunk down numbers that I'm going to be multiplying. 1 times 3 is going to be a 3. 1 times 4 is going to be a 4. So I've already dealt with those numbers. Now I can focus on the A's. There's an A to the first and an A to the third. Remember that when you divide like bases, you subtract their exponents. So this is like A to the 1 minus 3, and you put the result in the top. So this would be A to the negative 2. Okay? Then I can focus on my B's here. I got a B to the second and then a B to the first. So that's like 2 minus 1. So that would be B to the first power. So again, the results always go in the top. Now, before I'm done, I have to make sure I don't have any negative exponents, and I do have a negative exponent right there, so we do the inverse of its location. So it now joins the 4 in the bottom, and this is my simplified expression. There's lots of ways to think about simplifying these variables and their exponents. Another way of kind of maybe thinking about it would be just doing the subtraction or the canceling on the fly. So for instance, one of these A's would take out one of those A's, and one of these B's would take out that one B. You know, that's another way of thinking about it. If that helps you out. So either way, whichever way you want to think about it in terms of subtracting the exponents or just canceling them out on the fly, either one works because you do end up with the same answer. Quadratic trinomials, where I can do any of my factoring methods, I would recommend doing the grouping method. Go ahead and factor all 4 of those, and then you can write this in factored form and cancel out the factors that are there. This is the most complicated example we can give you. So what I'm going to do is I'm going to factor the 4 separately and then rewrite this in factored form. So x squared minus 11x plus 24. I'm going to factor that. x squared minus 18x plus 80. I'm going to factor that. And then x squared minus 15x plus 50. And finally, x squared minus 9x plus 20. So I'm going to factor all four of those individually, and then I'm going to put them back together as part of the factor form of this rational expression. Okay, so here I'm going to multiply the first and the last term, so that's the a and the c value. So that's 1 times 24, which is 24. Now I'm looking for the factors of 24 that add up to this middle term, negative 11. Well, right away that tells me that if two numbers multiply to give me a positive but add up to give me a negative, they're both negative. So I'm looking for two numbers that multiply to give me 24 but add up to negative 11. So in my head I'm just kind of running through 1 and 24, 2 and 12, 3 and 8, 4 and 6. I believe those are all the ways that I could get 24. Which one of those adds up to 11? Right here, 3 and 8. So don't forget your negatives, negative 3 and negative 8. So when I rewrite this 3-term polynomial, I'm going to write it as a 4-term polynomial and then group it. X squared and 24 are still my first and last terms, but now I split that middle term into negative 3x plus negative 8x to cover for the negative 11x. Now I group the first two, I group the last two. X times x minus 3 is what the greatest common factor result would be in the first term. Sorry, the first pair. And then the greatest common factor here would be negative 8. Remember that front number is negative. That gives me a clue. I need to pull it out. And I'm left with x and negative 3. The good news is those match. So x minus 3 is my common factor, and x minus 8 is what's left over. So now I can rewrite this portion of the expression as x minus 3 times x minus 8. So I'm going to do that now. X minus 3 times x minus 8. So that's the numerator of this first rational. Okay, moving to the next one. First term times last term. 1 times 80 is 80. So I need the factors of 80 that add up to negative 18. Same thing as last time. Multiply to give me a positive, add up to a negative. They're both negative. Okay, so I need factors of 80. That's 1 and 80, 2 and 40, 4 and 20, 5 and 16, 8 and 10. So then I'm looking for which one of those adds up to 18, 8 and 10. So don't forget about your negatives, negative 8 and negative 10. So now I can rewrite this as 4 terms. So I've got x squared minus 8x plus negative 10x minus 18. So here's my first group. Here's my second group. All right, greatest common factor of my first group is x. So that leaves me with x minus 8. Greatest common factor of my second group, negative 10. Oop, let me try that again. Oh, look at the mistake that I almost made here. This is an 80, and I put negative 18 right there. So let's fix that, because that would ruin my whole problem. Plus 80. All right, so let me pull out a negative 10, and I'm left with x minus 8. Now that's really good news because those match. X minus 8 is the common factor, and x minus 10 is what's left over. So now I can rewrite that portion of my rational in factored form. Okay, so I'm halfway done. 2 more. First times last. 1 times 50 is 50. Factors of 50 that add up to negative 15. So both will be negative. So I'm thinking about 50, 1 and 50, 2 and 25, 5 and 10, and that looks like they're going to be the winners, negative 5 and negative 10. So x squared minus 5x plus negative 10x plus 50. first group, second group, x times x minus 5 plus, pull out my negative 10, x minus 5. Greatest common factor is x minus 5. X minus 10 is left over. So now the numerator is going to be x minus 5 times x minus 10. All right, I've got one more to go before I can start canceling out. So, first times last, 1 times 20, that's 20. I need factors of 20 that add up to negative 9. Both numbers will be negative. 1 and 20, 2 and 10, 4 and 5. Those look to be the winners, negative 4 and negative 5. X squared minus 4x plus negative 5x plus 20. First group, second group. And I pull out my greatest common factor of x, leaves me with x minus 4. Greatest common factor of negative 5, which leaves me with also x minus 4. They match, x minus 4 and x minus 5. And that's my two factors that I can now start simplifying with. Okay, I cleared out all that work, and now we could just concentrate on simplifying. So I'm looking for tops and bottoms that match. Remember, you can find any tops to go with any bottoms in this multiplication problem. So for instance, this x minus 10 can cancel with this x minus 10, because ultimately when they all get multiplied, they would all be pushed together into the same fraction. So I'm allowed to go across not just tops and bottoms, but diagonally as well. But the x minus 10 has to go with some bottom in the rational